This is problem number 2 from section 9.4. In this problem they say, use Gaussian elimination with backward substitution to solve the system of linear equations. Write the solution as an ordered triple. Now, you can see that we have 3 equations with 3 variables, and we want to write these 3 equations into an augmented matrix. And the augmented matrix has an x column, a y column, a z column, and then a constant column. And we write our equation 1 across the top, equation 2, and then equation 3. So we're just writing the coefficients. We're ignoring the variables themselves. Now, what we want to do is we want to get this. Matricy so that we have 1s down the diagonal and 0s to the left. So what we want this thing to look like is, we want it to look like this type of matricy. Close to the identity matricy, but instead of having these up here on the right hand corner as zeros, we're going to have it look like 1, 1, 1, 0, 0. So we want that to look, we want this matrice to look like this. So how are we going to do it? We're going to start with the bottom left, then work to the middle left, then the bottom middle. So I usually go bottom left, and then bottom middle. It really doesn't matter which ones you do on the left side as long as you get these done first before you start working to the middle column. So here's how we work it. I can see on the top row and the third row that we have 1 and 1. So I need to change this one to a -1 so I can add them. So I'm going to say -1 R3, which means multiply -1 times the whole row. So I get -1, -1, 2, 6. And then I have -1, 3, 2, -6, 1, 2, 4, 15. Now I'm going to add row 1 plus row 3. That equals row 3. So that means I'm going to have 1 and -1 gives me 0. 2 and -1 gives you a 1. 4 and 2 is a 6. And 15 and 6 is 21. I'm going to rewrite the middle row, -1, 3, 2, -6, and then 1, 2, 4, 15 for the top row. So we got the bottom left-hand corner to be 0. Now we want the middle left to be 0. So we're going to take row 1 and add it with row 2, and that's going to equal row 2. When we do that, we get 0, 2 and 3 is 5, 4 and 2 is 6, 15 -6 is 9. And so on top we still have 1, 2, 4, 15. The bottom we've got 0, 1, 6, 21. So now we've got these 2 zeros. We just need this one to be 0 as well. I'm going to use the top. No, I can't use the top row to cancel this now, because if I use the top row to cancel, when I add it to the third row, the 1 will change this number from being 0. So after you get these 2 to be zeros, now you're just working with rows 2 and 3 mainly. So let's use row 2 and row 3 to do this. We need to change this to -5. So -5, row 3. So we're going to get 0, -5, -30. -5 times 21 would be -105. And then we'll get 0, 5, 6, 9, and 1, 2, 4, 15. Now we're going to take a row 2, add it to row 3. That's going to equal row 3. So I get 0, 0, negative 24, 9 and negative 105, negative 96. And then I have 0, 5, 6, 9, and 1, 2, 4, 15. All right, last step would be to make these bottom two both ones. Now, if we do this, or when we do this, we're going to basically take this times 1/5. So we're going to take 1/5, row 2, and we're going to take negative 1 over 24 to row 3. That's going to give you 0, 0, 1, 24 times 3, 96. No, times 4 is 96, times 4. Okay, so we got 4 here. This will give you 0, 1, 6/5, and then 9/5. And on top you've got 1, 2, 4, and 15. Now this is where backwards substitution comes into play. So we have at the bottom z equal to 4. So we can say one of our answers is z equal 4. We're going to substitute this into this equation by writing y, and we can write all these equations out. Let's write z equals 4. This is y plus 6/5 z equals 9 over 5. And then the third equation, or the first row, would be x plus 2y plus 4z equals 15. So the backward substitution starts here. I plug 4 in for z. I get y plus 6 over 5 times 4 equals 9/5. So I get y plus, this will give me 24 over 5 equals 9/5. When I subtract it over, I get y equals 9/5 minus 24 over 5, which is negative 15 over 5, which is negative 3. So that's what y is negative 3. We've got z is 4, y is negative 3. We plug both those in to find x. So we end up with x plus 2 times negative 3 plus 4 times 4 equals 15. This is x minus 6 plus 16 equals 15. Add the negative 6 and the 16, you get x plus 10 equals 15. Subtract the 10, x equals 5. So they said to write this as an ordered triple, so we end up with 5, comma, negative 3, comma, 4 as our solution. That's how you use Gaussian elimination with backward substitution.